created by MindSticks Foundation Trust.
Welcome, students. Today in this explainer, we are going to explore the absolutely fascinating journey of space physics. We have a lot to cover, starting with the principles of launch vehicles. Then we will look at ISRO's multi-stage PSLV, reusable space shuttles, the mathematics of escaping Earth's gravity, and finally, missions away from Earth. Let us dive right in.
Section 1. Principles of Launch Vehicles.
Let us begin by understanding the foundational science that gets massive, heavy rockets off the ground. The entire functioning of satellite launch vehicles relies entirely on a rule of physics you already know perfectly well, Newton's third law of motion. For every action, there is an equal and opposite reaction. When we are dealing with rockets weighing hundreds of tons, this law is the absolute driving force.
You can easily visualize this law in action. Think about how a deflating balloon zips around the room. The air is forcefully ejected out of the open end, pushing the balloon in the exact opposite direction. Or, consider your everyday Diwali rocket. When the fuel inside is ignited, combustion gas is forcefully expelled downwards. As a reaction to this massive downward force, a powerful upward thrust drives the rocket high into the sky. A launch vehicle is simply this very concept, scaled up to an incredible degree.
Section 2. ISRO's multi-stage PSLV.
Now, let us see how India's space agency, ISRO, applies this principle with real engineering. Notice the towering structure of ISRO's Polar Satellite Launch Vehicle, commonly known as the PSLV. The payload, which is the satellite itself, sits right at the very top, and the rest of this massive vehicle is almost entirely composed of fuel and engines.
Because rocket fuel is incredibly heavy, carrying all that dead weight into space would be terribly inefficient. So engineers designed a brilliant step-by-step process. The engines ignite and impart initial velocity, but once the first stage fuel is exhausted, that empty tank simply detaches and falls away, usually into the sea. Immediately, the next stage ignites, and the vehicle continues with significantly reduced weight and much higher speed.
The PSLV staging mechanism is wonderfully engineered to alternate between solid and liquid fuels across 4 distinct stages. Stage 1 uses solid fuel for that massive, explosive initial thrust off the launch pad. Stage 2 switches to liquid fuel, Stage 3 returns to solid, and finally Stage 4 uses liquid fuel to precisely finalize the orbit placement.
Section 3. Reusable Space Shuttles.
While the multi-stage approach saves weight, traditional launch vehicles are extremely costly because they can only be used once. To overcome this, the USA developed a different approach, the Space Shuttle, which looks much more like an airplane attached to external fuel tanks.
Let us compare the two. Standard launch vehicles are strictly single-use. Their expensive stages detach and fall into the sea, lost forever. Space shuttles, on the other hand, are reusable for multiple launches. The shuttle itself safely returns to Earth to land on a runway, and only the external fuel tank is discarded. This design saves a tremendous amount of money and resources over time.
Section 4. Escaping Earth's gravity.
Now, if our goal is to travel outward to other planets, we face a much bigger physics hurdle. A spacecraft must achieve what is called escape velocity. This is the absolute minimum initial velocity a spacecraft must reach to completely break free from Earth's gravitational pull and travel into outer space without falling back down.
How do we calculate this? We take the square root of 2 times the gravitational constant, multiplied by the mass of the Earth, and divide it by the radius of the Earth. Look at the massive numbers involved in these variables. The mass of the Earth alone is a 6 followed by 24 zeros in kilograms.
When we solve the equation with those numbers, we find a staggering minimum velocity of 11.2 kilometers per second. Think about that scale for a moment. Not per hour, students, but 11.2 kilometers per second. That is the speed required just to successfully leave our planet.
Section 5. Missions away from Earth.
Once a spacecraft achieves this incredible speed and escapes, the vastness of the solar system opens up to us. Consider our closest neighbor, the Moon. Even though it is the closest object to us, it still sits an immense 384,000 kilometers away.
To truly understand these cosmic scales, look at this fascinating comparison. The speed of light takes only 1 single second to reach the Moon from Earth. But our absolute fastest spacecraft, traveling at unimaginable human speeds, still takes 8 hours and 36 minutes to make the exact same journey. It really puts into perspective just how vast space truly is.
I will leave you with this challenging textbooks exercise to test your new physics knowledge. If the mass of the Earth were 4 times its original mass, how much time would a satellite at 35,780 kilometers height take to orbit? Think deeply about how gravity and mass are mathematically connected based on what we discussed. Try to solve this on your own. Keep studying, keep asking questions, and until our next explainer, keep looking up at the stars.